Here we are still in our section 3.2. Okay, in our last class we learned how to sketch a graph for a polynomial function, right? We did find the real zero of a polynomial function, and finding real zero means we are finding the x-intercept. Okay, so we find the x-intercept that give us output equals to 0. We also had a leading term test. Okay, and yeah, we talk about the polynomial function. Now, so today we'll talk about the, now let me start from an example here. Okay, and we'll just define what are these. So here we have this polynomial function. So this polynomial function f of x equals to x minus 6 cube times x plus 2 square. Okay, now here we can just rewrite this as a x minus 6 cube is same as x minus 6 time x minus 6 time x minus 6, and x plus 2 square is x plus 2 time x plus 2. Do you agree with this one? So we have x plus 6 3 times, right? And x plus 2 2 times. So our x minus 3, so x minus 6, so this x minus 6 is repeated 3 times. Okay, and x plus 2 is repeated 2 times here. And this here exponent of each factor. Okay, so we have this factor. So we have x minus 6 as a factor of this function, and we have x plus 2 factor of this function, and these factors are repeated. So x minus 6 is repeated 3 times, x plus 2 is repeated 2 times, and these 3 and 2, these are the multiplicities. Okay, so multiplicities is the number of times a factor is repeated, or multiplicity is the exponent of a factor. Okay, so here now let's go back to the definition here. Okay, so multiplicity means it's a number of times factor is repeated in a function. Okay, so if we have a function, let me just take something different function. So if we have a function f of x equals to x cube times x minus 2 times x plus 5 square. Now how many factor do we have for this function? So we have, this is our first factor, right? So we have x minus 2 factor, and we have x plus 5 factor. Now in here, how many times x is repeated? 3 times. X cube means x times x times x. Okay, we have x minus 2. It's 1 time, right? The exponent of this x minus 2 is 1. X plus 5 is repeated 2 times. And these 3, 1, 2, these are the multiplicities. Okay. Now, if the multiplicity of a real zero of a function is odd, it means if the multiplicity is odd, like 3, 1, okay, 5, 7, the graph of a function always crosses the x-axis at the corresponding x-intercept. So here we have a polynomial function. Okay, we write down our polynomial function in a factor form. We find the exponent of each factor. Okay, we find how many times factor is repeated, and that number of times the factor is repeated is the multiplicity. Okay, and if the multiplicity is odd, okay, if the multiplicity is odd, then that means the graph crosses the x-axis every time. Here in the graph, so we have this point, right? And at this point, what does the graph, what's the graph doing here? The graph has crossed the x-axis. It means, so at this point we have a x-intercept. Okay, at this point the graph crosses x-axis means the multiplicity has to be odd. So if we have the graph crossing x-axis means the multiplicity is odd. Now the next is if the multiplicity is even. Okay, if the multiplicity is even, then the graph touches the x-axis. Okay, like here. So graph touches x-axis means the multiplicity at this point is even number. So if the multiplicity is odd, the graph always crosses x-axis. If the multiplicity is even, the graph exactly touches the x-axis. Now in this example, so here So let me draw x-axis here. Now for this function, can you tell me what are the x-intercept for this function? Can you do that on your head? Finding x-intercept means we want to know x such that our output is 0. For what x value our f of x is equals to 0? Can you tell me what are the x values?
0, -2, sorry, 2, -5.
Okay, let's take 0. If our x is 0, we have 0 cube times 0 minus 2 times 0 plus 5. That is 0, right? So 0 is 1. So we have 1 x-intercept 0. Now if we substitute positive 2 here, we have 2 minus 2, 0. 0 times x cube is 0 and 0 times x plus 5 is 0. So positive 2 is also x-intercept. And if x is -5, this factor is a 0. 0 times remaining is a 0. So our -5 is also x-intercept. Okay. So now once we have the x-intercept, what is the multiplicity for this factor? So how many times x is repeated? 3 times, right? So it means at 0, so 0 is the x-intercept. At 0, the graph has to cross. So we're going to have a graph crossing the x-axis. It's always true. Okay. So when the multiplicity is odd, the graph always crosses at this point 0. Okay. Now for this factor, what is the multiplicity for this factor? So we have exponent 1, right? It is odd. It means the 0 is 2. The graph also crosses at this point, crosses the x-axis. Now for this factor, our exponent is even. Multiplicity is even. It means the graph touches the x-axis. It does not cross the x-axis. The graph crosses x-axis only when the factor has a multiplicity odd. If the factor is even, if the multiplicity is even, then the graph touches the x-axis. Okay. Now let's go to our example here. Now here it tells us to determine the multiplicity of the real 0 of the function. Does the graph cross the x-axis or just touches the x-intercepts? Okay. Now let's take the very first step is we write down. We must have a function in a factor form. Okay. To find the multiplicity, we must have a function in a factor form. So we already have a factor form for this function. We have a x minus 6 factor. We have a x plus 2 factor. Okay. Now let's find the 0 for this function. So let's find the zeros and multiplicities. Now can you tell me the zeros for this function? So zeros means what are the x such that our f of x is equals to 0. So for what x value this function is equals to 0? Positive 6 and -2. Do you all agree? We want x such that our function is 0. So if we choose x equals to 6, we have 6 minus 6 cube, which is 0 cube. 0 plus remaining is always 0. So 6 is 1 0 and x equals to -2. That is the other 0. So our 0 is positive 6 and -2. Now at 0 means these are the x-intercept. Okay, do not get confused. Zeros are same as x-intercept. Now at this x-intercept, does the graph crosses or touches? That is given by the multiplicity. Now for this x minus 6, how many times this factor is repeated? 3 times, right? The exponent is 3 and 3 is odd. Okay, this 3 is odd. Odd means does it cross or touches the x-axis? It's always cross the x-axis. Okay. Now let's take the next factor. So we have x-intercept -2 and this is from this factor. This factor is repeated 2 times. It means 2 is the multiplicity. It is an even number. So the graph touches the x-axis at this -2. Okay, so when we draw a graph here, your graph must cross at 6 on the x-axis and only touch x-axis at -2. Okay, now let me go back to our previous graph here. So we had this graph here. Okay, now so in this graph, the graph crosses the x-axis at -1, right? So crosses means the multiplicity has to be odd. Now let's check its multiplicity. So our function is, so did we write our function in a factor form? Okay, so we have this function. Let me write this function in a factor form. So this function can be rewritten. So we have a x common factor, x square minus 1. And we can factorize x square minus 1 as a x plus 1 times x minus 1. Now, at -1, so our graph crosses the x-axis. It means, so -1 makes this factor 0. And what is the exponent of this factor? How many times we have x plus 1? 1 time. It means the graph crosses here. Okay, now 0. So let's take this at 0, the graph crosses x-axis. Okay, so 0 means, so when our x is 0, so this expression is 0, and this x is 1 time, right? The exponent of x is 1 time, which is odd. So the graph has crosses here. Similarly, at +1, so 1 makes this factor equals to 0, and the exponent of this factor is 1. It is 1. So the graph has crosses the x-axis. So every time if the multiplicity is odd, it always crosses. If the multiplicity is even, it always touches the x-axis. Okay, and multiplicity is the number of time the factor is repeated in a function. Okay, now let's do the second example here. Now we have number b here. Now in number b, in order to find the multiplicity, we want our function in a factor form. Now, is our ht function in a factor form? So to be in a factor form means we must have in a product form. But here, see, we have t cube plus 2t square plus t. So we don't have a product in between this term. We have a sum. So it is not in a factor form. So we have to factorize this function. So, and the very first step of factorization is we look for the common factor in each term. Do we have a common factor in each term? T. So t is the common factor. So let's factor out t. And if we factor out t cube, so if we factor out t from t cube, what do we have? T square. So t cube divided by t square. And let's factor out t from 2t square. So that is 2t squared divided by t, which is 2t. And let's factor out t from t. T divided by t, we get 1. Now let's see, in between t and this expression, we have a factor form. So this is in a factor. But we have to factorize completely. Now, can we factorize that trinomial? Is there any way we could factorize this? We need to double check that. We can factorize this, okay? And we use FOIL method. So we have 2 factor. So what should be the first term so that its product is t square? So what should be the first term so that the product is t square? It has to be t and t. Okay. Now we find a 2 number. We find a 2 number here whose product is +1 and sum is equals to +2. So give me a 2 number whose product is +1 and sum is equals to 2. 1 and 1. So +1 and +1. Now we can rewrite this as a t time. So we have t plus 1 2 times. So this is t plus 1 square, right? Now we have our function ht. Now our function ht is in a factor form. See, we have a t time t plus 1 is square. So that's what we want in order to find the multiplicity. Okay. Now let's find the multiplicity here. So we're gonna need zeros for this function, okay, and we can write multiplicity. Okay, now zeros means for what t our function is 0. So what should be our t such that this function is 0? 0 and negative 1. So if you choose t equals to 0, so we have 0 times 0 plus 1 is square, that is 0. So t equals to 0 and t equals to negative 1. So when you choose t is 0 and t is negative 1, our function is 0. That's what we want. These are the zeros. These are the x-intercept. Now, so this factor t give us 0 here. Now, how many times this factor is repeated, or what is the exponent of this factor? 1, right? So it is odd. Odd means the graph crosses at 0 on the x-axis. So the graph crosses at 0. Okay, now how many times this t plus 1 factor is repeated? 2. So 2 is the multiplicity. It is a even. Even means the graph touches the x-axis at negative 1. See, if we draw a graph, we can draw, okay, let's double check. We can draw a graph for this function, okay, and check whether the graph touches our x-axis. Okay, now if we want to draw a graph, so let's draw our x-axis. So we know 0 is a 1 0, so we have this point. Our next x-intercept is at negative 1. Okay, now, so how do we draw a graph? What will be the end point here? Like, what will be the end behavior for this function? That's what we did in our last section. How do we know what is the shape of this function? So we need to know the leading term. Now, what is the leading term for this function? T cube, right? The leading term is t cube. What is its degree? Degree is odd, which is 3. What is its coefficient? 1. So we have an odd degree and coefficient positive. It means the graph has to look like this on the left end and this on the right end, and we don't know what happens here. Okay, so we're gonna have this shape on the left, so we can draw that on the left here. So left means at a negative 1 the graph is here, and at 0 the graph is here. Okay, that's what do we know from. Now we need to know what happens in between negative 1 and 0. So for that we choose a number in this interval. Let's choose negative 1/2, and we find the function is positive or negative at 1/2. Now when our t is 1/2, do we get a positive number or negative number? So t cube 1/2, cube of negative 1/2 is negative 1/8, right? So you substitute negative 1/2 for every t in this function, okay, and we get a positive or negative. So, or you can substitute here, it does not matter. Okay, now t cube, okay, that is, okay, let's do here. So we have negative 1/8. So 2 times negative 1/2 square. So negative 1/2 square is 1, positive 1/4 times 2 is 2/4, positive 2/4, and our t is negative 1/2. Okay, now let's see, do we get positive or negative here? So these two are the same, right? Can we cancel 2/4 and negative 1/2? These two are so this is 0.5 and this is also 0.5. So we have positive 0.5, negative 0.5, that's 0, and we have negative 1/8. It means we get a negative. Negative means the function, it has to, the graph will be below the x-axis. Now at 1, what happens? The graph has to, sorry, not at 1, at negative 1 the graph touches the x-axis. So from here the graph does not cross, it touches the x-axis and then it goes to 0, and at 0, see, the graph has crossed. So at negative 1 the graph touches x-axis, at 0 the graph crosses x-axis. Okay, so when the, see, at negative 1 the graph touches the x-axis because the multiplicity is odd, sorry, multiplicity is even here. At 0 the multiplicity is odd, it means the graph crosses x-axis. Okay, so with the help of multiplicity we know whether the graph touches x-axis or crosses x-axis. And to find the multiplicity we always want our function in a factor form, and we look for the how many times each factor is repeated, and that number of times the factor is repeated give us the multiplicity. Okay, okay, now let's do now here some of, so here we have the number of real zero. So if the, now here what it tells here is that, so the number of real zero of a polynomial function of a degree n is less than or equals to n. Now we have a function, we have a polynomial function of any degree, let's say degree 10. Okay, if we have a function of a degree 10, now what can we say about the number of zeros that function can have? So we have a function of a degree 10. Okay, then the number of zero means the number of x-intercept. Do not get confused here. So real zero means is x-intercept. So if you have a function with a degree 10 and the number of x-intercept that the function gonna have is equals to 10 or it's gonna be a less than 10. Okay, so here, so let's take this same function. So we have this function. What is the degree of this function? 3. Now if the degree is 3, it means the number of x-intercept that this function gonna have is equals to 3 or less than 3. Now let's go and check the number of x-intercept. Now how many x-intercept do we see here? So we have 1, we have 2. X-intercept means it's a point where graph touches or crosses the x-axis. Okay, so the degree is 3. So once we know the number of, once we know the degree, we can know how many x-intercept the graph can have. Okay, now let's check this one. So what is the degree for this function? So how do we find the degree of this function? So here, so we can rewrite this as a we can rewrite this as a x minus 6, x minus 6, x minus 6, and x plus 2 square is x plus 2, x plus 2. In order to find the degree, we want a leading term, right? The degree of leading term is a degree of function. And for that you multiply first term x times x squared times x cubed times x to the power 4 times x to the power 5. So x to the power 5 is a degree. So 5 is a degree. Now if 5 is a degree, how many x-intercept does this function gonna have? It the 5 or less. And how many real zero this function gonna have? 5 or a less. It can be equals to 5 or it can be less than 5. Okay, so that's the one principle here. Okay, the next here, the graph of, okay, now let's say our c is any number. Let's say we have a c or real zero of a function. Okay, real zero means when you substitute c for every x, you get output equals to 0. Okay, so if our c is a real zero of a function, then x minus c. Okay, so here, so if, let me rewrite. So if our c is a real zero, okay, so if c is a real zero, then x minus whatever number you have c is a factor, So you have any number as a real zero. Okay, let's say 2 is a real zero for any function. If 2 is a real zero for a function, then x minus 2 is a factor for that function. Okay, it's the other way. So now here, so we know positive 6 is a real zero, right? Positive 6 is a real zero means x minus 6 is a factor. So we have negative 2 as a real zero. So negative 2 is a 0 means x minus minus 2, which is x plus 2 is a factor. So when we have a factor, we can find the real zero. If we have a real zero, we can also find the factor. Okay, similarly here, so we know 0 is a 0, so x minus 0, which is t, so t is a factor. So negative 1 is a 0, it means t minus minus 1, t plus 1 is a factor. So if you have a factor of a function, you can find the 0. If you have a 0 of a function, you can find the factor. Okay, now that's what it tells here. Okay, let's do this example and it will be more clear here. So find a polynomial function f of x. So we need to find a polynomial function f of x. We don't know the function here. That's what we need to find. Of a degree 4. Okay, we know this function has a degree 4. Has zeros at negative 1 and positive 3. So we are trying to find a function whose zeros are negative 1 and positive 3. So if you are given a 0, we can find a factor. So if negative 1 is a 0, what is the corresponding factor? X, every time x minus 0, which is negative 1. So this is x plus 1. So x plus 1 is a factor. 3 is a 0. It means x minus 3 is a factor for this function x. So for this function f, x plus 1 is a factor, x minus 3 is a factor. Okay, so if you have a 0, you can write the factor with multiplicity 1. Now where do we write this 1? And 0 at negative 2 of multiplicity 2. Okay, so let me see here. So we have a function degree 4. We have a zeros at negative 1 and 3. Okay, each with a multiplicity is 1. Okay, and a 0 at negative 2 of, okay, now here we have, now what is this negative 1? That's the multiplicity for these two zeros. And where do we write that 1? So 1 multiplicity is the number of times factor is repeated. So for this negative 1, corresponding factor is x plus 1. For this 3, factor is x minus 3. And its multiplicity is 1, means the exponent of this factor is 1. It means the exponent of each factor is 1. So multiplicity is the exponent of a factor, or it is a number of times factor is repeated. So we have exponent 1, exponent 1. Now we have another 0 at negative 2. So if we have a 0 at negative 2, what is the corresponding factor? X minus, and this minus 2 0. So which is x plus 2. So this is the other factor. So we write down other factor x plus 2. And the multiplicity is 2, means the exponent is 2. So exponent is 2. So we have this exponent 2. And this is the function. And when you find the zeros of this function, this is what you're gonna get. Negative 1, positive 3, negative 2. And you can find the multiplicity 1 and positive 2. So you will be asked to find a function with the given zeros and multiplicity. Okay, so let's do one more. So here, and so we don't need this example. Okay, so I did add here. So in this section we are not doing the application of this function. Okay, so instead of this, so let's go ahead and just do our homework and practice these similar examples. So this is section 3.2. So let me do a problem number, okay, 99. This is your homework. Okay, so let me do 99 here. So 99, so degree is given as 3. Degree is 3. Zeros is negative 2, 5, 6, and each with multiplicity 1. So each with multiplicity 1. Multiplicity is 1 for each zeros. Okay, this is given to us, and we are asked to find a function, polynomial function. Okay, now we need to find the polynomial function. So in order to find the polynomial function, now we are given zeros, so we write a factor for each zeros. Now what is the corresponding factor when our 0 is -2? How do we write that? It's always every time x minus whatever 0 you are given. So it's x minus and this -2. So this is x plus 2. So x plus 2 is one factor. Okay, so we write down x plus 2 factor here. Now its multiplicity is 1. It means this 1 is the exponent for this factor. Okay, so 1 is the exponent for this factor. Now we have the second 0, 5. What is the corresponding factor for this 0? X minus 5. So every time, okay, x minus 5. So this is our next factor, x minus 5. What is this multiplicity? 1. So this 1 is the exponent for this factor. Now we have this 0, 6. What is the corresponding factor? X minus this 0, which is 6. So we have x minus 6. And the multiplicity is 1, and this 1 is the exponent for this factor. And we don't necessarily write the 1, so we can rewrite this as a x plus 2 times x plus 5 times x minus 6. Or you can write 1, okay, it doesn't matter. And this is the function, this is our function f of x. And if we find the degree of this function, you can use this degree to double check your answer. Okay, so x times x is x squared times x is x cube. So that is the leading term, and the x cube has a degree 3, so the degree 3 is correct here. So you can use this degree to double check your answer. Okay, so let me do, okay, 102. So 101 is your homework. Okay, let me do 102. So this is not your homework, but still let's practice one more. 102. So we have, so degree is 4. So degree for the function that we're gonna make has to have a degree 4. Okay, zeros are given as 2, -3 are the zeros, and we have 5 also zeros. Multiplicity is given to us. For 2, the multiplicity is 1. For -3, multiplicity is 1. For 5, multiplicity is 2. Now we need to make a function. Okay, we need to find the function here. Now what do? We take each 0, find the corresponding factor. Now let's take 2 as a 0. Let's take this 0. If 2 is the 0, what is the corresponding factor? X minus 2. So we're gonna write x minus 2 here. Okay, x minus 2. Now where do we write this multiplicity? This 1 is the exponent of this factor. Okay, next let's take this 0. For this 0, what is the corresponding factor? X minus, we have -3, which is x plus 3. So we have x plus 3 factor, and its multiplicity is +1. And where do we write +1? So it is the exponent of this factor. Let's take another 0, which is 5, and the corresponding factor is x minus 5. So we have x minus 5. And where do we write this 2 multiplicity? It is the exponent of this 5. Okay, so this is our final function. This is going to be the easiest problem. Okay, you will have this on your next exam, finding a function from a given 0 and multiplicity. Okay, you will have this problem. Okay, so let me give you one for you. Okay, and then we'll go to the next example. Or let's do number 97, which is your homework. Okay, and if you need help, I'll help you. So number 97 is h of x equals to -2x to the power 4 plus 4x cube plus 2x. Now this is a function, and you are asked to, okay, now you write this function in a factor form. That's the very first question for you. Rewrite this function in a factor form. It means you have to factorize this trinomial. So rewrite this function in a factor form. So factorize this trinomial. That is the first question. So how can we rewrite this function in a factor form? Yes.
You factor out the -2x squared.
Okay. Negative 2x square. Oh, okay. Okay, this is square. Okay, I missed. Okay, this is okay. That's right. So this is the last term is 2x square. Okay, that's right. So that's the very first step. So every one of you, so 2x square is a common factor, and we have the negative for the leading term. So we don't want negative for the leading term. So factor out negative 2x square. So let's factor out negative 2x square from each term. Now if we factor out negative 2x square from negative 2x to the power 4, what is that equals to? Is it negative 2x? X squared. Okay, you are dividing negative 2x to the power 4 by the common factor negative 2x square. So we get x square. Now 4x cubed divided by the common factor negative 2x square, we get negative 2x. Negative 2x. And positive 2x square divided by negative 2x square is negative 1. So we have negative 2x square. Now this is a trinomial. We can factorize using a FOIL method. What is the first term whose product is x square? The first term has to be xx, right? Now let's find two number whose product is negative 1 and sum is negative 2. Yes.
Actually, don't we need to use the quadratic formula?
Oh, now yes, we can't factorize this, right? Do we have any two number whose product is negative 1 and sum is negative 2? We don't have, right? It means we can't factorize. So we are not you don't need to use quadratic. So this is our final answer. The second. So whatever we have here is the final answer here. Okay, for 97 you are asked to factor the first expression. If not, yeah, you are only asked to write down in a factor form. Okay, yeah, that's what you need to do here.
For all of those questions,
So use this information to sketch the graph of this function. Okay, you are also asked to graph this function. For 97, okay, yeah, do not graph this function.
Well, the answers are 1 plus minus the square root of 2.
Oh, okay. If you get something is square root. Yeah, so it's not that we can't find. Okay, so you can just use the quadratic formula and just you can factorize this, but that's not what we want here. Okay, like for your homework, okay, I see you do have this problem, but on your exam you won't have this kind of, okay, you will have like a simple, so you will have a trinomial that you can factorize easily, like the one that we had earlier here. Okay, so here we did that similar example here. So okay, yeah, like this example. Okay, so you will always have the expression that you can factorize easily, and we can factorize this, but if you factorize this, you're gonna have a irrational number. That's what we don't want here. Okay, and for number 97, it's okay if you don't graph this function. Okay, so you just write down this function, write down the function in a factor form. This is the final answer, and you are not required to graph for this problem. Okay, so let's do another here. Okay, can you write a function? So let's do 104. So can you write a function which has a degree 3? Okay, 0 is at 5 and multiplicity, this is interesting. Okay, multiplicity is 3. Can you write a function? The function must have a degree 3. Okay, 0 is 5 and multiplicity is 3. Did you all have that? X minus 5 cube? That's right. So here, okay, I thought this one is interesting. Okay, okay, this is not work. Okay, but yeah, that's correct. So the corresponding factor is x minus 5, right? So multiplicity, this 3 goes here. So your function f of x is x minus 5 cube. Okay. Let me do number 1 type. Okay, 66. This is your homework. Okay, and I'm not sure we did cover, but it's still let's do this number 66. So here, so we have a graph given to us. So we have a graph here that is decreasing, crosses the x-axis, crosses this x-axis, then crosses y-axis. Okay, this is a graph given to us. So this is -3, this is -1, this is +5. And you are asked to write down the x-intercept for this function. Okay, can you tell me what are the x-intercepts? Do you all agree that is -3, or you can just write -3, -1? Okay, so x-intercept is -3. You can write in a coordinate form, or you can just simply write -3, -1. Okay. The second, you are asked to write down the y-intercept. Do we have y-intercept? Which is 5, or you can write 0, 5. Okay. Now, whether the leading term is odd or even power. Now, how do we know that? We don't know the function, but you are asked whether this is a function and this function has a leading term. And we want to know whether the leading term has a degree odd or even. It's going to be, is the degree for the leading term is even or odd? Even. And whatever the coefficient of the leading term, is it positive or negative? Positive. And how we know that is, we know this from the end part. Okay, so this is what we have on the left end, this is what we have on the right end, and we did do the leading term test. So if we have so we have this graph here on the left end, this on the right end, and this is the graph we get when our degree is even degree and the coefficient of leading term is greater than 0, right? See, so on the right, so this is what we have on the left, and we have pretty similar, and this is what we have on the right, this is what we have on the right. It doesn't matter what we have in the middle. Okay, similarly, if we have a graph that's, so this is what they have on the left side, and if they have this part of a graph on the right side, and the degree is still even, but the coefficient of leading term is less than 0. Okay, and if you have a graph something like this one, so what is the degree for this graph? Is it odd or even? Odd degree. And whatever the coefficient of leading term, it is greater than 0 or less than 0? Is greater than 0. And if you have a graph that's like this on the left end and this on the right end, degree is odd and the coefficient of leading term is less than 0. Okay, so you can do this one. Yeah, so this section homework is pretty easy. Okay, that's what I'm thinking. You might take yeah, for 91, 93, 95 you are required to graph. Okay, so you might it might take a little bit longer time, but I think you can easily do. Do you have any question from the homework if you have started? Okay, let's do this much. So we still have 5 more minutes. If you have any question,